Okay, Assalamualaikum. So we're again in tutorial chapter 8. This is question number 5. Okay, the figure 8.4 show a uniform ladder. So this is a ladder 3 meter long, and so this is the 3 meter long and a mass of 30. So we have mass, we have length. The ladder is at rest, so meaning the U is 0, and it's with its upper and again a smooth vertical wall. So your wall here we are smooth wall, and in the lower is a rough, so this is rough ground. The ladder is placed at the angle 50 degree with the horizontal. To maintain its position, sketch a free body diagram of this system and show the forces acting on it. Okay, so this question, what we need to do, we need to draw free body diagram. So the first one, our main character, our main actor here is the ladder. Okay, so kita akan lukis ladder. Okay, so this ladder, what do we have? We have weight, the weight, weight of ladder, and then because they touch the wall, so it have normal, and then they touch also the floor, we have normal. So we put normal A or normal B because he here and B here. So we have angle, and then after that, because it's the word rough, so we have friction. Okay, why is my friction is here? Because tendency, even though it's at rest, because the tendency, kalau you ingat balik, ingat tak ada soalan you need to press the dust, apa pemadam tu kan, so you need to press, so dia dalam keadaan at rest, so the friction will be upward. Why is not downward? Because tendency of the object is moving downward. So again, same with the ladder here lah, the tendency of the object is to moving to the, dia akan jatuh ke sana lah, dia akan jatuh menggelongso ke sana. So that's why my friction should be opposite direction dengan tendency kebarangkalian dia untuk jatuh tu lah. Okay. Alright, so this is my free body diagram. So ada NA, NB, friction and weight. Okay, that's all. So this is my angle of 50 degree. Okay, question number B. They asked you to calculate reaction forces at A and B. So we are talking about NA and B lah. So they ask you to find NA and B. Okay, so what we do, we just use the table. Kita guna table. Okay, forces X, Y. Okay, this one kita akan ada submission torque lah. Where submission torque equals to FD lah, ataupun equals to FR sin theta. FR sin theta. Okay. So if you look at here, my forces are the NA, weight, friction, and B. Okay, so ini saya punya ni. Okay, and then submission force saya, because dia adalah dalam keadaan rest, 0, 0, and submission torque saya adalah 0. Okay, so kita masuklah nilai. Okay, so my NA, so you look at my A, negative NA, 0. My weight is 0, W. My friction, okay, so because the friction is always opposite, so this is F lah, so this become positive lah. Sebab friction kan selalu ke negative, opposite direction, so NA become positive. So my NB 0, positive NB, so it's also 0. Okay, so how about top? Okay, for the first thing you need to know the pivot lah. So if the question doesn't give you pivot, so you need to choose the pivot that have many forces acted on it. So if you look at here, the point B ni, we have two forces, MB and B. So this is my pivot lah. So I can press ni, pivot at B. So my pivot is at B lah, ni A, ni B. Okay, so when my pivot at B, so what happened to the torque? Torque for NB and friction will become 0. Siapa-siapa yang duduk kat pivot, dia punya torque will become 0. Okay, so pivot ni you bayangkan you letak pembaris, you ketuk-ketuk paku. So NA you pusing, so dia akan jadi anti-clockwise lah. So anti-clockwise is positive, so NA, so from here to here, so this is your, it's not become your D lah. Sebab dia ada angle. So apa angle dekat sini? So angle dekat sini zigzag. You nampak ni zigzag. So ini pun 50 degree lah. So dia akan jadi, so 3, kita akan guna FR sin theta lah. Sin 50 degree. So itu saya punya NE lah. Okay, and then look at my weight. Okay, my weight is going down. Okay, so kalau ini saya punya pivot, saya pusing, dia akan jadi clockwise. So dia negatif lah. So negative W. Okay, the distance here kita akan choose separuh because weight always half. So this one 3, so separuh akan jadi 1.5 lah. So dia akan jadi 1.5 sin K. Kenapa sin? Because the distance from here to here adalah bukan D, dia ada angle. If you look at here, you have angle here lah. So you akan ada angle sini. So angle sini because this one is 90 degree, this one 50, so this one akan jadi 40 lah. So saya akan pilih 40 degree. So inilah sin 40 degree. Okay, so saya dah dapat ni. So apa the next one yang saya perlu buat? Okay, so saya akan selesaikan lah. So kita akan selesaikan dia menggunakan submission lah. Kita buat. Okay, so question number B kan. So submission mula-mula sekali kita buat menggunakan submission X. Okay, Fx akan sama dengan NA minus F equals to 0. So NA saya akan sama dengan friction. Okay. Yang kedua saya ada submission Fy sama dengan negative W plus NB equals to 0. So my NB akan sama dengan weight lah. Okay, so soalan pertama tadi dia suruh cari NA dengan NB, right? So NA, friction, kita tak tahu nilai friction. We don't have the value of friction lah, tak boleh buat. NB sama dengan weight. So do we have weight? Yes, we have weight tadi. Weight dia ada bagi tadi. The weight of the ladder is 30 lah. So we can get the NB lah. 30 times 9.81. So here you will get the answer is 294.3 Newton. So this is your NB. Okay, so this one kita akan start. Tak boleh buat lah. So we cannot use any. So we left with this one lah, torque plus. Ni. Kita left dengan torque. So kita akan guna submission torque equals to NA3 sin 50 minus W 1.5 sin 40 degree equals to 0. So here, if I bring the whole thing here there, so I will get NA3 sin 50 equals to mg. So weight, this is weight, 39.81 sin 40 degree. So I will left with my NA only lah, so I can get my NA. So here I will get my NA is 123.4 Newton. So this is my answer lah for number B. Alright, so we move on to the last question. Number C, they ask you to calculate the coefficient of friction. So they ask you to calculate mu. Okay, so we want to find mu. Okay, so here, so we want to find mu. Okay, number C, we want to find mu. Okay, so what do we know? We already have the N, right? So we already had A and B, and we know that NA equals to this one, the first one. NA equals to friction. So we can say that NA equals to friction. Okay, my NA is 123.4 equals to friction. Friction is mu N. Okay, what N here? Okay, the friction happened at B. Look at the friction is happened at B. So that's why N here is referred to NB. Dia refer kepada NB lah, bukan NA lah. Formula, yes, NA equals to friction. But friction, the original formula is mu N. But N here is referred to the where dia duduk lah. So your friction tadi duduk dekat point B. So my mu equals to 123.4 divided by NB, the one that you will get tadi, 294.3. So your answer will become 0.42. So no unit lah. Kenapa no unit? Because this is a coefficient. Alright.